Hey again. I was struggling to type this, so I'm just going to do a quick little video. Really, I want to make sure that the outcome of that Newton's second law lab kind of clicks in your brain before you start looking at those problems in the Google Slides doc. If we think, probably the easiest way to see it is if we think about that second part of the lab. You were asked to graph MA on the one axis and F on the other axis. It gave a nice straight line, and when we did the math, the slope, or when we got Google to do the math, the slope of that line was 1. The point of all this is whenever we have a straight line, we can do y equals mx plus b. What was cool about this particular lab is the b value is 0, so we don't have to worry about that anymore. Y equals mx plus b, but really it's not y. On the y, it's m times a. Similarly, it's not x, we graphed f. So instead of y equals mx plus b, I'm going to say ma, because that's really what y was. The slope happened to have a value of 1, and that was equal to f. A normal way to write that is we flip-flop things around and say f is equal to m times a. That is the equation for Newton's second law. F is equal to ma. There's little bits of cool things buried in it. First of all, unit-wise, if you've got a force in newtons, that comes from taking a number in kilograms and multiplying by a number in meters per second squared. As we go farther in physics, what you may see down the road is people will say something like newtons per kilogram, if we flip the kilogram over, is exactly the same as meters per second squared. That's just the magic of the metric system. It works out that if we push something with a force of exactly 1 newton, that if we were pushing a 1 kilogram object, 1 newton would make a 1 kilogram object accelerate at 1 meter per second squared. From this line, I kind of remind you back to that 9.8 number. 9.8 told us when we did, oops, that's supposed to be an arrow. 9.8 told us how strong gravity was. 9.8 is how many newtons are on a kilogram. And if something free falls, 9.8 is how rapidly something accelerates while it's free falling. Another kind of little thing is in the lab, we didn't have to deal with friction. So really, if there is friction, we would say that the acceleration is really related to the F net. You'll see that when we start doing problems. If there's a friction force, we'll treat it as like a subtractive thing to take away from the overall impact of what we're going to call the applied force. One last little bit. If I were to rewrite this one more time, we'll switch back to red. We could say that A all by itself is F over M. If you think back to that first, before actually doing the lab, the one document I posted that gets you thinking about the lab, this is the common sense part of it. How quickly something accelerates is directly proportional to the force. The harder you push something, the more it's going to accelerate. So the F is on the numerator. And that just got really messy. Let's try that again. So how something accelerates is directly proportional to the force. Push it harder, it's going to accelerate more. We're going to add an F net for when we deal with friction, but that should have been hopefully a little bit intuitive. Push it harder, it accelerates more. The other part was it's inversely proportional to the mass. If you push something really heavy or really massive, it's not going to accelerate as much. Sometimes I call that the teeter-totter effect. Something with a light mass will accelerate more. As mass gets smaller, acceleration gets bigger, and vice versa. If you push something really massive, the acceleration isn't as big. Hopefully that was a little bit of an intuitive when you did the very first document related to the lab. Push something harder, it's going to accelerate more. Push something that's more massive, bigger mass, will have a smaller acceleration. That was supposed to clarify things. Hopefully it does. If not, shoot me an email, and maybe as you start working through the questions that I've posted on that Google slide document, those answers, maybe it'll make more sense when you see it in action. Thanks. Stay safe.